everybody again. And this time it's a very short part of lesson 9.1. Let's start. Some special sequences. You should be able to recognize the following patterns and sequences. So here are the sequences. Square numbers, which we all know. The nth term is n squared. Square number is a product of multiplying a whole number by itself. Square numbers can be represented using dots arranged to make squares. Square numbers form the infinite sequence 1, 4, 9, 16, 25, 36, and so on. Square numbers may be used in other sequences, like these. A quarter, a 9 plus 16 plus 25, and so on. And 2, 8, 18, 32, and 15, where each term is double a square number. Cube numbers. A cube number is the product of multiplying a whole number by itself and by itself again. So it's like a 3D version of a square number. Cube numbers form the infinite sequence 1, 8, 27, 64, and 125. And the nth term of the cube numbers is n cubed. Triangular number. The nth term of the triangular numbers equals 1/2 n open bracket n plus 1 close bracket. Triangular numbers are made by arranging dots from either equilateral or right-angled isosceles triangles. Both arrangements get the same number sequence 1, 3, 6, 10, 15. Triangular numbers form the infinite sequence like that. And here's one thing that connects all square numbers, cube numbers, and triangular numbers. If you add the first square number, it is the first triangular number. If you take the first cube number, it is the first triangular number squared. If you take the second cube number, it is the second triangular number squared. If you add these together, and when you add the first three cube numbers, it's the first triangular number squared, and so on. How cool is that? It's really nice how these things that seem almost different from each other, well, not square and cube numbers, they seem almost the same to me. But square numbers, cube numbers, and triangular numbers are related to each other in some way. Well, there are sequences. Okay, onwards. The next sequence is the Fibonacci numbers. Leonardo Fibonacci was an Italian mathematician who noticed that many natural patterns produce the sequence 1, 1, 2, 5, 2, 3, 5, 8, 13, and 21. These numbers are now called the Fibonacci numbers. They have the term-to-term rule. Add the two previous numbers to get the next term. So, that was a short but exciting part of lesson 9.1. Thank you and goodbye.